Hi, I'm Ellen. I'm Lil's wife. I wanted to thank Gary a lot for inviting me to come talk about what it is that I do, and this all sort of
Oh,
started. What, Gary?
I said, sorry. Yeah, this is great. Great.
Excellent. Um, yeah, I'm gonna kind of go through this. I think I'm gonna mostly take questions at the end. I sort of tend to do these as more of a storytelling thing than a sort of here's a good place to actually stop and ask questions thing. Um, so this all started because Lily and I talk a lot about the code that she's using to analyze her experiments because I am a professional software developer.
Well, I
It,
create the experiments.
yeah,
Sorry, should I not interrupt you? I'll stop. Sorry.
love you. Uh, anyway, I am a professional software developer in that I am paid to write, review, and think about code all day. I write code for mobile operating systems, mostly iOS, but sometimes Android. I've been doing it for about 10 years now. I write mostly in two programming languages called Swift, which is mostly used for iOS, and Kotlin, which is mostly used for Android. And I'll get back to specific languages a little bit later in the talk, but I have used these skills for years at a bunch of different agencies, a couple in Chicago and one in Amsterdam, but all of which had lots of different clients who paid the assorted teams at the agency that I worked at to build lots of different stuff. And they start by telling you what they want, and then they will tell you what the budget and timeline are that you have to build it on. And you have to try to make it look as much like the brief as you possibly can on that budget and timeline. I've also worked for a couple more normally structured companies like Spot Hero, where I came in as their first full time mobile developer. I built up an entire iOS and Android team over the course of about 18 months before we moved to the Netherlands. And now I work at Apollo GraphQL, where I write code that goes into an SDK or software development kit that's used in a lot of different iOS apps. So basically, I write code that helps people write even more code. So there are a lot of people who hear this and think, well, that's pretty cool, but can you fix my printer? This includes a all of my family and a good chunk of Lily's family. Um, One place I don't fall into this meme, though, is that I don't have a computer science degree. My terminal degree is the BS degree in radio, television, and film production, which my parents agreed after I got it that yes, that does sound like a BS degree. So how the hell did I wind up where I am now? I started where I suspect some of you are right now by desperately failing and trying everything I possibly could to try and figure out how to get something to work, and then repeating that process the next time I had to figure out something new. And I'm going to slightly spoil the rest of this talk by telling you that honestly, this is still basically what I do all day, just with a much, much wider base of knowledge because I've been doing it for 10 years now. And that's because there are two key things about programming that it really helps to internalize. The first is that there is a lot to know. Even in the fairly small slice of the programming world that I work in, mobile development, one site that I write for has over 40 books on advanced topics for iOS and Android. And my friend Paul, who is an absolute madman and former journalist who can churn out loads of content in a terrifyingly short amount of time, he has written 18 books by himself about iOS development over the last 5 years. But it's not just the volume of what you need to know. It's the fact that building up knowledge to the point where it becomes expertise tends to reveal that even as you get to know more, you find out just how much more there is to learn. I'd like to think that I'm in the middle of this like third expert phase, but honestly, even after 10 years of doing this, I'm still pretty firmly in that hazard section. Um, and while in any field, the more you learn, the more you can see the terrifying depths that you can go to in your learning. One thing that's much more specific to coding and tech is that even if you dive really deep in and get to know everything you're supposed to know at one point in time, what you need to know is changing all the damn time. It is my full-time job to keep up with some of this stuff, and it feels damn near impossible. As an example, there's this one technology within iOS called Core Data, and it's basically how iOS interacts with databases. And the book the team I work with is now on its eighth edition. Every year, Apple introduces new stuff that people want to learn about and also deprecates old code. Deprecation is a nice way of saying, hey, we don't want to deal with this anymore, so we're warning you before we delete it that it's not going to be here in the future. So that team has to go through that book at least once a year and often rewrite significant chunks of it. Because some things may be easier because Apple has done a bunch of things to make them simpler, but then they may let you do more things that you couldn't before, so even more chapters need to be written. And this is because across all kinds of computers, things are quickly getting more and more and more powerful, which in theory would allow us to do the same thing in a much shorter amount of time, and it does, which is sort of the problem. Because in order to fill up the time and continue to challenge ourselves, professional programmers have tended to make things way, way more complicated. And there's certainly advantages to a lot of this complication, but it can make a lot of things harder to keep up with and harder to learn. And I've often had people that I've been mentoring ask me how on earth I remember all of this stuff. And the obnoxiously true answer to all of that is that I don't. I seriously could never keep this amount of knowledge in my head. When I say that I am a professional software developer, what I really mean is that I am a professional at figuring out where to find answers for my questions and how to craft my questions so that search engines and Q&A sites actually give me useful information back. And this is the super annoying thing when you're learning a new technology, because you have to relearn what to Google in order to get relevant and helpful answers. Because when you know what to Google, you can generally get to the answer about what you need pretty quickly. But if you don't even know what the question is you should be asking, you have to start somewhere. And the starting places are often things that reference other starting places, such as this sentence that I found when trying to figure out how to explain Node Package Manager to Lilia, which was, if you have experience with Ruby, NPM is just like gems. Now, if you don't know what Ruby is, you will stare at this sentence and wonder if they're talking about actual physical rubies and jewelry or some technology you haven't worked with before. And it's maddening. And after an hour of trying to help Lilia work through getting NPM installed and figuring out what it does and trying to understand it, she sighed, she turned to me, and she said, "I don't know how you have this job. It's like hell on earth." And I admit, this is a hugely frustrating part of dealing with programming stuff. But it also leads to the biggest piece of advice I have about learning to program. It's not you. I know it can feel impossible and it can make you feel stupid, but the first thing you have to do is forgive yourself and realize that even professionals start from a standpoint of thinking that computers were a mistake and will stab you in the back when you're not looking. In fact, I have found the more years of experience you have programming, the likelier you are to eventually tweet the phrase, "computers were a mistake." Now, some of you may wonder how this is supposed to be inspiring, because after listening to a professional say this, you may want to curl into a ball and never think about R or NPM or Python ever again. And I understand that. Because most academics are in a position where they just need whatever programming they're doing to work so that they can analyze their data or collect more data. The idea of spending tons of time to write well-crafted software is a farce, because you also need to read 50 pages of dense research papers, teach a class, and then try to write a grant to get more funding. And programming is not necessarily a skill you want to hone more than you really need to get things done. And this is what I call means to an end programming. And it can be really, really hard if you're just trying to complete a task to look at things that are designed for professional programmers who are willing to and able to spend days trying to figure stuff out and get them to work. So I want to offer a few tips, trips, and deep dark secrets for you. I will start with a deep dark secret. The way modern software works is kind of a house of cards. Lily had asked me about how much stuff depended on JS Psych, and I showed her this cartoon about modern web architecture being entirely reliant on a project some random person in Nebraska has been thanklessly maintaining since 2003. This is actually, weirdly, kind of how it's supposed to work. Especially in the JavaScript world, you're supposed to be able to rely on software other people have proven works so that you don't have to reinvent the wheel and you can focus on the core of your own problem. And this works really well until it doesn't. My favorite example of how this house of cards can really blow up came in 2016 with what's known as the LeftPad debacle. These few lines of code that are just in this lovely little 11 lines, this was LeftPad. All it did was add more spaces to the beginning of a line. but tons and tons and tons of things depended on LeftPad, and tons of other things depended on those things, and it was used a lot. And the guy who maintained it got into a snit with NPM because they gave a package name he had to a company that filed a copyright complaint against him. And they're like, well, legally we have to do this. And he was like, the law doesn't mean anything, man. And so he just deleted his entire set of stuff from NPM, including LeftPad. And because so many things depended on LeftPad, this did not end well. This is from a story in the Register about LeftPad. With LeftPad removed from NPM, these applications and widely used bits of open source infrastructure were unable to obtain the dependency and thus fell over during development and deployment, thousands worldwide. LeftPad was fetched 2,486,696 times in just the last month, according to NPM. It was that popular. So, after hearing that something that 2.5 million people a month were using could just be deleted, breaking half the internet, you may be thinking that this whole system seems really tenuous and easy to break. And that is because the whole system is really tenuous and easy to break. And particularly for people who aren't professional programmers who deal with this nonsense every day, it can be really discouraging when things that are supposed to work together just fall apart. It is important to remember that this stuff is not your fault. This is not you being a bad programmer. This kind of thing is what professionals are referring to when they say that computers were a mistake. You are far from alone in your frustration with this entire system. And speaking of not feeling alone, another thing that's important to remember is that making silly mistakes is a common problem, and you should not beat yourself up over it. There are entire comic strips about how programming can make you absolutely hate your life until you realize that you've just misspelled the name of a variable, and fixing that fixes what you've been staring at for 2 hours. This stuff happens to me all the time. I rage tweeted about having spent 2 hours wondering why my whole networking stack wasn't loading anything, and then realizing that for the gazillionth time, I forgot to call the method that makes it actually execute the request that I've handed it. And it's not a coincidence that this got 23 likes. This is a thing that iOS developers forget to do all the time. When stuff isn't working, you can't beat yourself up. You can't just sit there thinking, what am I doing wrong? One of the hardest things for me to take in when I started, and I think this is true for a lot of other people who are super overachievers, is that when code doesn't build or doesn't do what you want it to do, that failure is not a sign that you are a bad person or a dumbass. It's simply a sign that you've made at least one assumption about how this should work that was wrong. Because if everything worked the way you assumed it did, then your code would have worked. And that leads to a much more productive question. What was the assumption that you made which wasn't right? Because then you can start to go through an iterative process of figuring out what the incorrect assumption was, and you can find out what you need to change in order to make something work. And to make it fancy, professionals call this debugging, mostly because in the olden days of computers, they literally would have to pull moths out of the computer because they were attracted by all of its flashing lights. The assumption causing the problems was that this program is not affected by actual literal bugs. Nowadays, you're far less likely to run into something that obvious, so you have to take a more investigative tack. And this is actually my favorite quote on the subject. Debugging is like being the detective in a crime movie where you are also the murderer. You have made the incorrect assumption, but you are also the one trying to figure it out and fix it. And looking at debugging as a mystery is a great way to realign figuring out what assumption was incorrect. And occasionally, your code will try to give you clues about what's not correct. In typed languages like Swift and Kotlin that I normally code in, if you define a method and then say, okay, this takes a string. If you try to pass an integer through, your code won't even build and you'll get this nice clue of what you've done wrong. For untyped languages like Python, when you define a function, you don't provide any information about what the expected types are to the system. And if you do provide the expected types, in this case 2 integers, it works totally fine and adds them the way that you expect it to. But if you go back and you say, okay, I'm going to hand this a string and an integer, this will not bring up any warning until you try to run it, since there's not really a way to know what the types of each parameter here are supposed to be. But when you do run it, Python is not going to be able to make it do what you want it to do. This last piece here is the clue that you need to figure out what your incorrect assumption was. In this case, you thought you could pass any type to this, but the types needed to be able to be concatenated. And sometimes you can wind up with reams and reams of information in your logs. But the fact that it can give you useful information is why you absolutely should not ignore it. If you're working on something simple, the error can be simple. And if you're working on something complex, the error will be more complicated. But in either case, these logs are trying to help you figure out where your incorrect assumption lives. It may be hard to wade through all the info the logs are trying to give you, but they are trying to help. Speaking of which, I want to share a note about code comments, because there's this sort of assumption in some places that if you write code that's clear enough, you don't need to actually add any comments to that. Personally, I think that's nonsense. Writing code that completely expresses what it's doing and why it's doing it is almost impossible. I have personally found that code without comments is going to be regretted, usually at about 2 a.m. So for professional programmers, I generally recommend that you name functions with a plain English description of what they are. Don't use single letter variable names. It's not like we're still running on 8 bytes of RAM where the size of the variable name actually makes a difference. And then you use comments to explain why you're doing what you're doing. For people who program less frequently or who are newer at programming, adding more comments can be a huge shortcut to remembering what it is you were even attempting to do. It's really easy to forget what you were doing or what a specific function means when you haven't looked at the code for 6 months or a year. You have to keep your comments up to date, but having a lot of them will be way more helpful to figuring out what's going on in code that you haven't looked at in a while. Another thing that can be really helpful is warnings. Only some languages support this, but even if you're just adding print statements for languages that don't, it can be really helpful to have something that you can define to remind you to do, or more often not to do something, and have that show up either in your code or in your console so that you have a regular reminder to deal with it. Now, these can become easy to ignore if you use them too much, but using them sparingly can be a really, really helpful thing. Another thing that can be really helpful in this vein is what's called rubber duck debugging. The general concept is pretty straightforward. You try to explain what your code is doing to someone who has never seen it before. But since people can be awfully judgy, you actually explain it to a rubber duck. And what's helpful about this is it forces you to think about things in a way that takes everything you're doing from scratch into account. While rubber duck is helpful, you can also use a real person. I always joked that my friend Isaac is the world's best rubber duck, because anytime I'd call him over and start to explain a problem to him, about 95% of the time I'd get halfway through the explanation and realize exactly what I'd done wrong, because I wasn't thinking about that part of the system when I was fighting with it before. And I'd turn to him and say, "Man, thank you, Isaac." And he'd cheerfully say, "Okay," and walk away, having done absolutely nothing, but still somehow making me feel like he had helped immensely. From here, the next piece of advice I have is to keep trying to make things work. Often things will not work on the first try. I've currently got 3 branches of something I'm working on because I know what I have isn't great, but I'm not that confident yet in any of the solutions I've come up with. But I'm not going to give up. I'm going to keep trying to come up with something better. And that may sound kind of painful, and sometimes it can be. But I think the thing I found over the years is that the more you try something, the more obvious what you need to not do becomes, and the path to actually getting stuff done becomes much clearer. And at a certain point, nothing is ever going to be perfect. You may want to spend a long time refining something to make it as stable as possible, but you cannot let your desire to do the best possible thing get in the way of getting something out the door. If you need to improve it for something in the future, you always can. But if it's doing what you need to do right now, ship it and move on with your actual research. And finally, if there's one thing I want you to take away from all of this, is that when you hit something you're stuck on, your absolute best option to get unstuck is to ask for help. And part of this means you need to find places where you can do that. Because while there's a rising tide lifts all boats mentality in a lot of tech, that means people spend a lot of time asking each other questions and trying to figure out whether something isn't working, or is it just me, or is it the system itself, or what's going on here. Academia is a lot more competitive, and there's this sense that you need to keep whatever knowledge edge you have to yourself, because otherwise you are totally going to lose at Thunderdome. This is how a lot of older and larger tech companies used to work, but as things have gotten vastly more complex over the last few years, a lot of full-time programmers have realized that everyone defensively hoarding what they know instead of trying to help each other is really counterproductive. Instead, people have worked to create meetups specific to whatever they're working on. And these can be found all over the world. And if you think, well, that's not that many, you can zoom out to thinking about data science using Python, and there's all of these meetups. There's even a ton of meetups for R, which I know a bunch of you guys use for statistical analysis. And one very thin silver lining of the pandemic, keeping everyone at home, is that a lot of these meetups have gone virtual. You can join meetups almost anywhere in the world, an enormous number of which are in English regardless of location, and get information that's helpful. You can also seek out affinity groups like PyLadies or other groups specific to whatever language you're working in. These will often have an invite-only Slack or Discord instance, which makes it a lot easier to ask questions you think make you look stupid. A related piece of advice to that is that when you're trying to figure something out, there is no such thing as a stupid question. You're asking the question not because you're dumb or dense, you're asking it because you need to know the answer. And that's why a corollary to this is, while there's no such thing as a stupid question, there is definitely such a thing as an asshole answer. People who are judgy about basic questions from beginners have totally forgotten what it's like to be a beginner and can consequently be complete jerks about it. I poke a little fun at Stack Overflow, but they have been working to try and make their community more hospitable to newer programmers with somewhat varying results, but they are at least trying. The biggest thing, nobody knows everything. It is impossible given both the depth of what needs to be known and the speed at which it changes. And as someone who just wants to be able to move things forward, sharing what you know in exchange for what other people know can only help you and can only help the people you are exchanging knowledge with. Because let's face it, you're actually out there trying to solve problems. You're not just throwing an algorithm at the wall to see if it can fix a problem, which it turns out you need the domain knowledge that academics actually have in order to solve it. I hope this has all been helpful, and thank you for letting me yap at you. Love to hear any questions or feedback that you have.